Okay, today we go to the 8.1. Okay, pressure in fluid. Okay, fluid, the meaning is liquid, either gas. We also can using the word for fluids. Okay, so now can I start? Are you ready?
Yes, yes.
Okay, so we continue. Okay, let's see the chapter 8.1 about the pressure in the fluid. Okay, concept of the pressure in the fluid in an enclosed system. So we need to know the word is an enclosed system. Means the system all is closing. Don't have any air can go in. We call enclosed system. Okay, you can see this one diagram. Actually, everybody know lah. You go to workshop, sure you can see this one, the hydraulic jet that can lift the car. After that, the car lift up. After that, you want to change the tire when you pump it or want to do something. So this one hydraulic jet, they're using the concept of the enclosed system. That means inside don't have any air bubble. So inside got liquid. Okay, got liquid. After that, you need to pump. Okay, you need to pump the liquid. After that, they can using the piston to push the car move upwards. Actually, if we're using our hand, you want to lift the car, actually it cannot work. So we need something to help. So this one hydraulic jet, that means you just provide a little bit force. You provide the force, that means you go to jet. You go to jet only. Finally, they produce bigger output force to lift the car. Okay, so inside there, who's help you to lift the car? Actually, it's a fluid. The liquid now is moving. When the liquid just moving, when go to the output, they got another piston, big piston to push. They produce the bigger output force. Then they can lift the car. So we go to explain. This device, they operate based on the effect of the pressure in hydraulic fluid. Okay, inside they got fluid. Okay, after that they got pressure and the enclosed system. So that means inside must be closed. You cannot open. If you open, that means they got air bubble. If you got air bubble, when you just press, you produce a pressure. This one pressure, actually you press the air bubble. You not press the liquid. If you press the liquid, liquid will transfer. Then they lift up the car. You got air bubble, that means you go to press, you overcome the air bubble first. Baru you go to overcome the liquid. So that's why the whole system must be closed. We don't want got any air molecule to disturb the whole process. Okay, number 2. Enclosed system in physical system where the matter cannot enter or leave the system. So no air bubble in, then inside the liquid also cannot out. Okay, either liquid, either gas also cannot out. They must trap inside already. So we call this one is an enclosed system. Okay, number 3, in hydraulic system, the fluid transfer the applied pressure. When you press, actually got pressure. Okay, then the pressure transmit. Okay, transfer to another side. So who's help the pressure to transfer? The fluid. Okay, liquid help to transfer. Gas also can help to transfer. So that means when I just jet, when I'm using my hand to jet the lifter, actually I produce the force and pressure in the system. So this one system inside got liquid, then they help to bring, just now I jet the pressure, go to output. Then the output also got pressure. Okay, so how make the force can double and triple bigger? Why become like this? Now we're going to see the system. Okay, transmission of the pressure in the liquid. Okay, example, how we see, squeeze of the top page. Okay, you squeeze the top page tube. How does the pressure exert by the thumb, okay, transfer to the mouth of the tube? So you press, okay. Now you can find this part no more, it become flatten now. So another side become bigger size already. So the touchpad, they will go through the mouth after that come out. So that means you transfer, you create the force. So now the top page, just like the liquid, they transfer go outside. Okay, so that means if I close the mouth, what happened? You find it this part become bigger size, because all the all the toothpaste is concentrate at that part. So you find it become bigger size. So that means the pressure actually is transferred when you go to squeeze. So the pressure is transferred from the place where you press by the thumb to the mouth of the tube in every part of the liquid. Okay, actually you press, this one we call enclosed system because you don't have any air to go in. When you just press already, the pressure must be transmitted. Okay, go another side. So another example like this. I push the water into the piston. This one is a piston. Okay, piston got some hole. I go to put the water in, then after that I need to push. I'm using the force to push the piston. Now you go to observe. The water sure flow out lah, flow out the water. So from the Pascal piston, explain why the observation become like this. So the water, they flow out equal speed. You see the every speed also is the same. Make sure the hole is the same lah. Don't tell me the hole is bigger lah. So every hole is the same. When I just compress, the water spur out, sure is the same speed. The pressure transmit in every part of the water equally. So that means when you just press, actually you apply the pressure. Then your pressure apply to everywhere. So if got hole, that means the pressure for every hole is the same. So that's why they got pressure to add the liquid to come out. Okay, so this one is you create the force, then produce the pressure. Then the pressure must transmit equally. Okay, berpindah secara seragam kepada semua arah. Okay, go to any way. Okay, they do not block one. Okay, so we need to go through Pascal principle. So Pascal principle is talking about the just now process, pressure transmit. Okay, first one, we need to know Pascal principle definitions. Pascal principle, they state that the transmission of the pressure exert on the fluid. So the fluid is either liquid or either gas in an enclosed system. Okay, the system must be closed. Then the pressure must uniform. Okay, transfer uniform throughout the fluid and in all directions. So that means the Pascal principle, they're talking about the pressure. The pressure will act to the liquid or gas. Then the system is what? Closed system. Then the pressure acting must be uniform. Okay, don't have big and small, always constant. Through the fluid in all directions. So that means you can see this one example. If I push the F, okay, you can see P2 also got moving, P4 also got moving, P3 also moving. Then if the diameter is the same, actually all the pressure is the same. Okay, all the pressure is the same. So from here, you can show this one. Just now diagram, when you press, all the hole also get the same pressure. Then the speed come up is the same for every hole. So this one will be related with the Pascal principle. Okay, apply the pressure in the fluid. After that, the system is an enclosed system. Then the pressure must be uniform. Then acting to all directions. Okay, so this one is one of the activity actually you can do by yourself. Okay, you take one mineral water. Okay, after that you put the hole, make a hole, 3 hole different level. Okay, they make highest, middle, and the bottom. Okay, then you fill in all the water in the mineral water. So you're using the cellophane tape to close first lah. Okay, never apply any pressure. Then you just open the cellophane tape, you let the water to flow. Okay, so you can find it the Z. The Z is the bottom one. Okay, the water will be spurred further. Okay, why? Because the pressure is the highest. The lowest one means the depth is bigger. Depth, kedalaman. Okay, depth we measure from the top until bottom. This one we call depth. We never from the bottom go up. Depth must from the surface come down. We call depth. So Z is the bottom one. So the Z sure got high pressure. What pressure? Water pressure. So the water pressure acting high. So that means the hole at the bottom, the water come out must be further. Okay, So the distance further means that one is the highest pressure lah. So compared to the Y and also the Z. Okay. So number 2, I go to addition pressure. I go to squish. I go to squish the bottle. Sure, you find it. Every hole, the speed of the water double. They will increasing one, sure. Because you add the pressure some more. Okay, you add the pressure, let it to go further. So that means the pressure when you just add, because this one is enclosed system, they cannot go anywhere. So they just can go to the hole only. So that's why you're acting the pressure, they will transmit to every hole. Every hole also can get it. Okay, so you find the Z, they will plus another D, Y also plus D, then X also plus D. So this one D is you create one, because you create the pressure. So from here, they based on this one, first one figure, water flow from the bottommost hole shoot out the furthest. The last one, the bottom one, that's the furthest compared to the water from the upper hole. Okay. Then the B, if the force apply, you go to apply. So to the water surface by compressing the closed plastic bottle. Now the water from every hole also will be shoot out, but now it's further. Okay, at the equal addition distance. Okay, every one addition must be equal. You cannot say, oh, this one plus 4, this one plus 2 only, this one plus 3. No. Okay, if plus 2, everyone also plus 2. Okay, just the Z still furthest. Okay, because they're at the bottom, the pressure should be the highest. Okay, now, okay, the question, in which part does the bottle shoot the furthest? Okay, just now I explained for you, the furthest sure is a Z lah. Okay, the furthest is a hole, the very bottom one. Okay, the last one. So explain your answer, why the very bottom one that should be go furthest. The reason is because the water pressure increase with the depth. Okay, remember, deeper part, when you go to the deep sea, you find your ears, the pressure acting to your ears is very high. So you find your ears is very pain. Okay, because the pressure already increasing. Okay, so this one is related with the pressure and also the depth. Okay, so from here you can see the hydraulic system. So hydraulic system, they're using the concept of the pressure lah. Pressure go to move the liquid. After that, produce the output force. So you can see the diagram actually like this. We're using this one called hydraulic system. Inside is a liquid. Okay, inside the system there's a liquid. Then this one liquid normally we using is the oil. Okay, we're using the oil. Just like your car brake. We're also using brake oil, is it? Okay, so from here, the important is the piston. Can you see the size is different? One is smaller, another one should be the bigger. The bigger ones normally is for the heavy load. Benda yang berat. Because you want to lift. Okay, you lift the car up. So this one is a force you go to apply. Okay, when you just apply, actually you compress. You compress the liquid. When you just compress, you produce the pressure. Then the pressure will go to the output. Then the output produce bigger force. Then finally, the car also can be lifted up. Important is the area. Can you see the piston 1, piston 2? The area is different. If you create the piston 2 is bigger area, then you can produce bigger force. So that means this one area is the main point to make the output force increasing. Okay, so now we're going to see explain the basic principle of the hydraulic system. There's a transmission of the pressure in all directions. Okay, based on the Pascal principle. You can see they transmit in all directions. Then hydraulic system is used to do for the heavy work. They do the heavy work. Example, produce a larger output force to lift the heavy load. So you go to the workshop, you want to repair the car. So the workers, they just press one button. Then your car can lift out already. So that one is hydraulic system. they're using the small force. After that, the piston is very big. Then they transmit the pressure. Then your car can be lifted up. So your car is a heavy load. So this one system we call hydraulic system. Okay, now we're going to see the different thing structure. First one, you must have the force to lift it. The handle, you must lift first. Okay, number two, you must see small force is used to lift the larger load. Only using small force. Okay, what's the difference? Two piston with different surface area. Okay, the small one, sure you lift one. Okay, you lift the part, the piston sure smaller because you no need using more force. Okay, after that, the output one, you want to lift the car up. That one sure is a. Okay, all the red color is what? Okay, all the red color is a fluid, liquid. The liquid will transfer the pressure uniformly. So that means the pressure, how many for the first piston? Output the piston, the pressure must same. Must same. The pressure cannot loss. Sure will same. Why pressure same? The output also very bigger force because of surface area. Surface area bigger, they will affect the output force. So we're going to see the explanation. First, the system must be closed. Number two, two-cylinder piston with the different surface area. Okay, number three, the fluid to transfer the pressure uniformly. Okay, number four, function to use to lift the large load with only small force. Then, what principle we using? Pascal principle. Make sure you know when they see the hydraulic system for this one, lifting the car, hydraulic jet, you need to explain these 5 points. First, the system must be closed. Number two, two-cylinder must be different size. Okay, the input one sure small, output one sure bigger. Then the fluid we need to using must be oil. Then they will transmit pressure uniformly. So what's the function for this whole thing? They used to lift the larger load only by using small force. What principle? Pascal principle. Okay. So we continue to see this one from your textbook. You can see this one is a small piston. Then they go to apply 10 Newton. They apply the force 10 Newton. Then this one area is how many? 2 cm squared. Okay, this one is a liquid. Now the liquid uniform pressure transmit until go to larger load. Okay, this one larger piston, the area is 100. Okay, big enough already, is it? This one 2 only, this one already is 100. Okay, then they lift up the load. Okay, so from here, two-cylinder piston, sure different surface area. So one is 2, one is 100. This one is important because later we need to calculate this one load is how many. Okay, I'm using 10 Newton only. Then I go to lift. The load can be up. I want to know this one load actually is how many weight. So finally I can lift the load. So from here, the fluid commonly we use is oil. Why using the oil? Because the oil is prevent rusting. Rusting we call what? Malay we call it perkarat. We want to prevent perkarat for the system. And also do not compress easily. Oil is not easy to compress. If you're using water, water easy to compress. But the oil hard a bit. So that means they're not easy inside got a bubble if you're using the oil. Okay, if got a bubble, that means the whole system become not efficient because you need to overcome a bubble. So the whole system must know a bubble. So from here we get the info for this one diagram. 10 Newton F1 force. A1 is a surface area for number 1 piston. F2 is the output. F2 for the load we do know. Okay, this one force how many we do know. But the piston area we know there's 100. Okay, So now we continue to do the calculations. Okay, according to Pascal principle, the pressure exerted by the small piston same as the pressure produced as the large piston. Okay, just now Pascal principle say already, pressure transmit uniform. Okay, pressure never lost. If you put how many pressure in, output sure is how many pressure. That's the same. So we write the equation. Pressure at the small piston equal pressure at the large piston. Okay, for the Pascal principle. So now I need to create the pressure formula. Okay, pressure formula actually is a force over area. Okay, force over area is a pressure input. So pressure input is a force over area. So this one all input lah. Input force, input area. Okay, then you equal to the output. Output force over output area. So this one is a formula for Pascal principle. So from here, it follow just now information. Just now information, sorry, I go to repeat this one. This one is a symbol. I change the word become symbol. F1 over A1 equal F2 over A2. So this one is the first piston. 2 is an output piston. Sure, the F2 is bigger, like is it? Because the surface area is bigger. So we go to proof. So from here, I go to show the info first. Just now the info. F1 10 Newton, F2 do know. A1 is 2 cm cube, cm square. Then the A2 is 100 cm square. So I'm using the formula to calculate the F2. Okay, then I continue. Okay, 10 Newton. This one is a 10 Newton, is it? So I put here F1. Then this one is a A1. A1 how many? 2 cm square. Then F2 do know. Then the 100 is a A2. Okay, you give me the answer for F2. Okay, I want the answer for F2. 500 actually. S3 give me already. 500. Telling Newton.
100.
500 must have unit. The unit we follow the question. Because they say force is a Newton. So we just follow. Okay. So the answer is 500 Newton. Okay, don't just press calculator, give answer. When the question come up for structure question, you need to do calculations. Okay, although you know you get 500, but you need to show the way how you get 500 Newton. Okay, so this one's a question for the pressure. Okay, we continue for the second question. Okay, now you can see this one also is a enclosed system, hydraulic jet. Okay, apply the small piston. Okay, this one is the info first. Okay, F2 is 800. Finally, the car can be lift up. So lift up how many force? 8,000 Newton. Okay, after that, they told you area number 1. Area piston 4 cm square. Then the A2 is 100 cm square. But the F1, don't know. They apply how many force? Don't know. Okay, can you give me the calculation to show the answer for F1? No need show calculation. And just straightforward give me the answer. Because you type calculation very hard. Okay, give me the answer for F1. Okay, Charlotte already give me 320 Newton. Okay, we go to check. Okay, I show calculations. F1 over A1 equal F2 over A2. F1 don't know. You just empty. You put F1. Then 4. Then 8,000 over 100. So we get the answer 320 Newton. Okay, the question just like this only is simple. Important you understand the question. Okay, so finish for this one calculation. Then we need to see application. Where we use Pascal principle. First one sure is a hydraulic system. Just now I told you. Okay, this one is a hydraulic system. Just now lifting the car in the workshop. Okay, beside that we're using for the brake system. The car brake system. Another one is a tenter chair. Okay, you go to see the tenter. They call you to slide down there, is it? After that, they press the button. After that, you can lift up. That one, they're using the hydraulic system. Okay, used to carry out the heavy work using the small force. Okay, so you are very heavy, you know how to lift up your body. So they're only using a button. Okay, so that one button, that means they just like you go to compress. After that, the pressure, bring the gas, bring the liquid to go. After that, they lift up your body. So that one is the output piston. So from here, 3 example where the Pascal principle apply in the daily life. They got hydraulic jet. Hydraulic jet is just now the workshop one. Okay, hydraulic brake, that one is your car brake system. And the last one is a tenter chair. Okay, this one is a 3 example apply for the Pascal principle. Okay, so we go through one by one. Okay, this one is a 3 thing we need to go through. Okay, first one, we go to hydraulic jet. Okay, lifting the car. You can see the whole car also can be lifted up. So this one, okay, we start used to heavy load, you to lift the heavy load such as a car in the workshop. So the first one, you can see you must start from the lever. This one is a handle. You need to move the lever first. The lever is moved downwards and upwards. You need to move up and down repeatedly. Then you push the load large piston upward with the release valve closed. Make sure this one valve is closed. Because when you just move, actually the liquid is moving. You see the valve, this one must be open. The valve let the liquid to go to the larger piston. So number 2 is this part. The liquid transfer go to the larger piston. Then the release valve please close. Okay, so you need to repeat it. Up, down, up, down, up, down. Finally, the load can be up to the higher. Okay, now up ready. How to come down? So you must open the release valve. When the release valve just open, now the liquid will slowly to come back. So you find the load large piston will drop back to the original position. They will slow, they never fast one. Don't tell me you go to workshop, you repair the car. After finish, you press button, then your car come down. No, they should slowly to move down. So that means that one is a release valve. They let all the liquid flow back to the reservoir. So that means your car can be moved downwards. So this one is a process for the hydraulic jet system. Okay, last one should be the release valve. Okay, then we go to the first one, operation for the hydraulic jet system, increasing the height of the load large piston. Okay, this one's a diagram just now I show you. This one more detailed a bit. Okay, the lever is moved downwards and also release valve and move valve A close and valve B open. Okay, you can see this one is a valve A. This one is a valve B. 2 valves cannot open together. They're sure either one close, either one open. So you see number 1, lever is moved downwards. Okay, number 2, the piston exert the pressure on the liquid. When you just move down, they're acting the pressure. Okay, so when you just acting the pressure, now all the liquid move already. Okay, this one close, valve A must close. When you just go down, all the liquid move already. You don't let the liquid to come out already. So the liquid move to the valve B. Valve B must open because you want to let the liquid go to the large piston. Okay, this one release valve sure close, can open one. Okay, when the valve B just open, all the liquid go here. So the liquid transmit pressure to the loaded large piston and push upwards. So your large piston rises a bit lah. So this one process you need to repeat. You need to repeat when you just up. Okay, when this one level up already, this one close. This one close first. Then this one will open. The liquid will come out from the reservoir. Second time you press, then the liquid move again, go to the valve B, then you load up a bit. So you need to repeat. Repeat up, down, up, down, up, down. Finally, the load can be up. Okay, understand about the hydraulic jet. Okay, important you know, down, the piston will go downwards, then the pressure travel. Okay, the pressure will travel from where? From the input to output. Through what? Through the liquid. Liquid help to travel. then go to the last piston. Then the piston inside got liquid also, then the liquid will push the output, the force acting to the load, then up a bit. Then you continuous. So the large piston is raised up. Okay, this one number 1, number 2, number 3, then this one number 4. So the process is 4 process. Okay, now we go to the maintaining the height or position of the large piston. Okay, so from here they say position of the large piston is maintained. Okay, number 1, just now you down already, is it? Now on the up. Lever is moved upwards. Okay, when you move upward, what happened? Liquid from the reservoir flow below the small piston through the open valve A. Okay, now you can see the B closed already. A is open. Let all the liquid come out because just now you send here already, no more liquid, not enough. So the liquid must be come out from the reservoir lah. When it just come out, okay, number 3. Okay, a constant liquid pressure is exerted on the large piston to maintain the position because they close already, ma. The liquid cannot out already, so they maintain the height. Okay, the pressure in the liquid keep push the load, so the load cannot come down one. They maintain. So number 4, the position of the large piston now is a maintain, never drop. Okay, because the release valve you close already, the liquid know where to go. They only can push the load. So finally, the load still maintained. Okay, so third part, I want the load to come down. Okay, lower the large piston back to the original. So if you lower, first step, you must release valve open. Okay, release valve must open. Then you can see this one, the valve A is open. Valve A is open. This one B must close already. You don't let the liquid terbalik to flow. You want to let all the liquid go to the release valve. Okay, number 2, load large piston, exert the pressure liquid beneath it. Now the load is acting down. When it's just acting down, the liquid sure got pressure. The pressure go where? Valve B closed already, so they cannot go to valve B. They only can go to the release valve. So number 3, the liquid flow back, okay, to the liquid reservoir through the release valve. Okay, so that means when I go to the reservoir, then the valve A is open, then never mind lah. This part also got liquid. It's okay. Important, I want to make the larger piston, the liquid out first, so the object can be dropped. So this one's a process, how the hydraulic jack to lift up the object and fall down the object. Okay, hard a bit, So we're going to see the operation for the brake system. This one is your brake system, the car brake system. So first one you need to see is the number 1. Number 1 is the brake pedal, the brake pedal. Okay, you need to using your foot to press the brake. Okay, when you press the brake, actually what happened? You can see the yellow color. Okay, this one yellow color is a brake oil. Okay, brake oil. The brake oil, they will transmit. When you just press, the brake oil will transmit the pressure. You can see number 2. Number 2 is here. You bring the liquid to go to back. Then you bring the liquid go to the front. Because front we go back because the brake, they want front wheel and back wheel. Depan punya roda and belakang punya roda. So that means actually we got 2 brake. Okay, for your car. Okay, first one, the front one we call disc brake. Okay, disc brake, you can observe your car in front. The tire there, the brake is just like the CD, the disc one. Okay, CD shape. Circle, after that, a little bit shining. That one is a disc brake. Then you go behind. Behind the wheel, you can see the brake just like the drum. Okay, they cover with the one of the metal. After that, they're just like the drum lah. We call it as a drum brake. Okay, we go to the first one. The brake pedal is pressed. Push in the master cylinder. Okay, this one's a master cylinder. So exert the pressure on the brake oil. So the first step, you exert the pressure to the brake oil. So this one master cylinder sure very small cylinder. Then the output one sure is a big cylinder because you want to produce bigger force. Okay, number two is a liquid flow. The pressure is transmitted uniformly by the brake oil through the metal pipe to the brake cylinder of the front and also the back wheel. Okay, two also must transmit equal. We don't have say, oh, in front one I let more force, outside one, the back one I put a little force. No, the pressure transmit must be the same. Okay, force different because of the piston. Okay, because of the different piston. Okay, normally they say the in front wheel, they were using more force because you want to suddenly emergency brake. Okay, you're using more of the force apply for the in front wheel. The behind one a little bit. So that's why they say the tire, they need to do the balancing. Okay, behind one normally they can more tahan because you never use so much. So the grip, normally they do the balancing, they bring the behind wheel go to in front. Okay, let all the grip finish. After that, the four tire need to change lah. So that one is in front and behind. What's the difference? Okay, we go to the 1 and 2 is a similar. In front and behind is the same thing. You press, the pressure will transmit. I don't care you are in front brake or behind brake. The brake oil sure will transfer. Okay, now we see what's the difference. Okay, differences for the in front first. This one is a disc brake in front. Okay, disc brake of the front wheel. Okay, this pressure push the piston in the brake cylinder, which passes the brake onto the steel brake in the disc brake. So you can see the yellow color. Okay, yellow color from the master, then go down. Then they go in the tube. You can see two tubes. Both sides also got tube, number 3 and number 4. Okay, this liquid they will press. Okay, they will press the, this one is a steel blade. So you can see 2 pistons that will press the brake. Finally, the brake dish, then the brake pad that will acting by the force. Then finally, they make your wheel, the front wheel become stop. Depan punya roda akan stop. Okay, because of this one, the dish, they compress. Okay, compressed by the liquid. So finally, they make the wheel, the in front wheel, they stop immediately. Okay, because of this one, the force transfer. Okay, left and right. Okay, the wheel, left and right must be the same piston. Don't tell me the left side, the piston is bigger, and the right side, the piston is smaller. Then when you brake, how to brake? Left can brake, right cannot brake. So normally it's the same. Okay, roda, kiri, kanan must be the brake dish, must be the same size, piston. Okay, so that's why they produce the force is the same. Okay, how about the back one? Okay, this one's number 4. The friction force between the brake pad and also the steel plate will slow down or stop the rotation of the front wheel. So 2 will take the road, brake pad and also the steel plate. Okay, this one you make the car wheel will be slowed down. Okay, for the back also is the same. You can see for the back is a drum brake. Drum brake at the behind, not front wheel. Okay, I'm going to change first. Back wheel. This one is a back, not front. Okay, this one is a back wheel. Okay, we go to the back wheel. Okay, number 3. Part number 3, this one. The pressure same. Push the piston in the brake cylinder. Then presses the brake and also the shoe. This one is a brake shoe. We got brake shoe. You see this one brake is a different. They're just like one of the circle. They're just like the drum. Okay, just now no. Just now is one of the piston like this. This one is a drum. So you see they got brake shoe onto the brake lining onto the drum brake. Okay, that means just now the yellow liquid that we press to the orange color. The orange color is a brake shoe. After that, beside the orange color, we got brake lining. That one is a red color. So finally, number 4, this one friction between the brake lining and also the brake drum. Okay, lining and brake drum. So they will slow down or stop the rotation of the back wheel. Okay, because of these two things. Okay, the lining and also the drum. Finally, they stop the back wheel. Okay, important must have this one yellow lah, the yellow oil. This one is a liquid transfer. Okay, so remember, in front we call ditch, behind we call drum. Okay, concept is the same. Okay, so this one just show for you for the brake system. Okay, and the last one system is a tenter chair. Okay, tenter chair. The operation of the tenter chair is related with the hydraulic system. The downwards and upward position of the tenter chair apply the hydraulic system. Same lah. They just go to press. After that, you can lift up. Then after that, they go to press. That means you can come down. They just like the concept for the hydraulic system. Okay, so okay, project is it? Okay, important. You can see this one is a one of the project. Okay, actually, I want you to do. Then you see they're using piston only. Then just create the tenter chair. You can see example. Okay, the press. They can lift up. Okay, then they press another piston. The seat can be lift up. So I want you using the piston to create the project. So same PowerPoint and also video. Okay, now I explain for you what you need to do. This one is an example. Okay, so this one's the activity 8.4 from your textbook. You need to design a tool using a principle of the pressure of fluid. Okay, example like this also can. Okay, you can see that using the piston, piston inside got liquid lah, you put the water. Then after that, this one piston can lift another side. Another side for what? They want to lift the heavy load. Okay, they lift the heavy load. Finally, the thing can be up. So our lesson just until here. Okay, bye everyone.